see, where were we? So let's talk about data frames for a few minutes while we still are, awake and alert. For learning objectives, if we get to them, we are going to, this is much more relevant to what an applied scientist would actually do. Like before was pretty much basics. We're still not going to do any stats, but this is like part of the pipeline. You have to get the data into a format you can use before you can do anything on it. We're going to take CSV spreadsheet data, read it into R. We're going to learn what a data frame is, and we're going to learn about tidy data. That's a certain way the data is formatted. That it's the same way, basically, that SAS would take in data and R, most analysis programs. And we're going to do some manipulations on the data, and we're going to calculate summary statistics like means and group values and stuff like that. Very common things. And hopefully it will be very empowering once you learn how to do them. So what's a data frame? I mentioned data frame last time, but we didn't actually meet any data frames in person yet. A data frame is a data structure that's like a table or spreadsheet of data. So it has rows and columns. Obviously, that's kind of like the main way that data are organized these days. And columns in the data each have their own data type. Just like, in one column will be the treatment label. So that's either a character or a factor. Another column is a measurement that's a numeric and so forth. And ideally, if your data are well organized, each row will correspond to an observation. So like this individual has this weight, this, whatever concentration of nitrogen and so forth. And so the data frame, basically every type of data analysis and data manipulation you'll do in R will be using data frames, almost without exception. So you got to know how to work with them. We're going to, last time, except for CalSay, we didn't use any packages. We're not going to use CalSay anymore, sadly. That was the last you'll see of CalSay in this curriculum. But what we will see is a package, or really a set of packages called Tidyverse, which is a set of packages that kind of work together that make it relatively easy to write code to manipulate data in R and process data frames into a way you can use them. And it's a package. There are functions in base R that aren't in any packages that basically do the same thing. There's also a package called data table you may have seen. But Tidyverse seems to be the easiest for beginners to learn, I have found. And others have found too. And so that's why I'm teaching off of it. If you really start to nerd out on this, I would recommend learning other ones, but Tidyverse is a good starting point. So the first thing we're going to do is call library parentheses Tidyverse on top of our script. Here's lesson 2. Library parentheses Tidyverse, Control Enter. It loads a bunch of packages, and it's basically loading a bunch of packages at once. They do different things. One is for plotting, one is for manipulating data, one is for working with strings, one is for importing data and that kind of thing. It checks them all to see if they're up to date. So we're all good. Now we have a data frame called smallmammals.csv that is, or it's not a data frame yet, I'm sorry, it's a CSV with data in it that we're going to import and turn into a data frame to work with in R. And if you are not on Deposit Cloud Server, you can load it from this URL. I just put this CSV on the internet so that you can download it. But if you're on the oh yeah, I have the URL in here, so that'll everyone will be able to do that anyway. I also have it saved in this folder called data as well, which is all the data for the few days. But it doesn't really matter either way. Let's read it from the URL. So read_CSV is the function that we're going to use to read in the data and import this CSV and turn it into a data frame. It gives us some information. It read in a 1629 row, 7 column data frame with values So if all you need to type here is the read_CSV. The remaining part is just the URL of the data. Normally you would import this from a file on your local drive probably, but you can also read in CSVs directly from a URL. Yes, you can. You can, but it's better to do it scripted so that you can reproduce without clicking. And I'll show you also that I did save this to a folder called data. So instead of typing the URL, you can also on our demo server, there's a folder called data where the data sets live. So this will work too. So I called it SMAMLs is the name of the object that we just imported. It's a data frame. What is it if you care? These are body measurements of small mammals that were caught in small mammal traps that are set out at a bunch of sites around the country in the National Ecological Observatory Network. And they kind of catch whatever they catch and record their species and their body mass and how long is their hind foot, which is apparently a good index of the body condition of a little mouse. So let's look at how we can get some summary information about a data frame. And this will use the special methods that tidyverse has to get summary information out of data frames. One good way, if you are using a tidyverse data frame, is just type the name of the data frame into your console and hit enter. And so let's just type SMAMLs in. I already have it here on line 13. You can just hit Control Enter. You can see it'll print the first few rows of it. It'll tell you the data type of each column, like the site, taxon ID, all the species have an identifier code and their sex, adult versus juvenile, and some measurements on them. You can see that the data type, each column has its own data type. Some are character and some are numeric. And this only prints a few rows, but you can use the print command to print as many rows as you want. N is the number of rows to print. We can print the first 50 rows using this command, Control Enter. So we can print the first 50 rows as well. Yeah, as many as you like. Some other ways to get summary information from a data frame are the summary function, and the str function structure from base R. Glimpse is another function from tidyverse that gives you some summary. There's just different ways to look at the data frame. Summary is nice because if we do summary of some mammals, it will tell you summary stats on the numeric columns, like hind foot length. It'll give you the min, median, and max, and how many NAs there are. Those are the missing values. So there's 52 missing values in the column of hind foot length because the mouse ran away before they could measure its hind foot length. It's just NA. Well, I believe that if you look at the raw data of the CSV, a blank value, it's just going to be blank. And if R sees a blank, it will put NA there. Yep. Yeah, so yeah, and then glimpse is another one. Glimpse tells you the first few rows in a different format. There's just a bunch of ways to look at that. Yes, that was summary was the function I used. Summary is a function. It takes input in parentheses. The input is the name of the data frame. So we're saying do the summary function on this data frame called SMammals and get back the result. Print me back the result. Yes, I also want to show that you can index data frames in the same way that you can index vectors. Remember how we got letters and then we got the first one and the 20th one and all that. But With data frames have two dimensions, rows and columns. You have to specify which row and which column you're going to index this time. So row, comma, column is how you do that. If we want the second row and third column, it will use a small mammals bracket 2, comma 3. That'll be row 2, column 3. 2, comma, you can put a space at the comma 3. So it's the third column was family. It gives you the third value. It gives you a 1-by-1 table basically with the with that value in it. And you can get entire columns and all rows in a column or all columns in a row. If you leave the column blank, it'll give you the fifth row, all columns, 5, comma, blank. And if you say don't tell it what rows to get, it'll just give you the column, the entire column. So 5, comma, or blank, comma 2. I'll just type that in the console here. Mammals, bracket 5, comma. That'll be one observation with all the measurements from that observation. And S mammals, comma 2 will give you, yeah, that's the species ID column. It'll give it to you for every one of them. That's how you'd pull out just one column. Yes, and you can do that with ranges as well. If you wanted rows 6 through 10, you would do it the same way we did with vectors, 6, colon, 10. And you can do that for both the rows and the columns. I won't show that example, but you can feel free to type that in if you want to. Another way you can get columns, the columns have names as well. So it's usually better, instead of typing numbers in, which may change the order of the columns, it's usually better to extract columns by specifically typing the names in. And you would use that C function to create a vector of column names in quotes as characters if you want to pull out more than one column. So if we want row 20 and 2 different columns, the taxon ID and the sex for row 20, we would say row 20, comma, and then pull out the taxon ID and sex that way. So yeah, like you could put 20 or whatever you want to put, and then put on ID in quotes. Again, it's case sensitive, and in the data frame, taxon is lowercase and ID are uppercase. You have to put that, otherwise it will say undefined column selected. You have to put it just like that. So there's that. There's also the $sign operator is used to pull out single columns from a data frame. If you want to get a single column as a vector, like if you want the site name column as a vector, you would put S mammals $sign site name, and that'll pull out just that column. Yes, so we could do that. Site name, N in name is capital. That is the National Ecological Observatory Network standard way of naming the columns. So here are all the site names. There's, whatever, 1,600 of them because we pulled out the entire column. And I wanted to do that because I wanted to illustrate how you can, if you wanted to do functions on just one column of a data frame, you need to pull that column out and do stuff with it. If you want to have a function that takes vectors as an input, you would pull that column out of the data frame, and then by pull out, it's still in there. You're just pulling it out and making a new variable out of it, even though it's still there in the data frame. Unique would be a function you can use, which if you have a categorical variable, it will tell you all the different unique values in that vector. So you could use unique, and table is another one that counts the occurrence of each value. So let's try that just to show you how to do that. Unique is the function, and then it has parentheses. The argument is this site name vector that we pulled out of the data frame. Control Enter. So this is only a subset of the data. There's 4 sites. in the data. Those are their names. And table also. And we'll use that site name. Control Enter. And it will give you the counts of each one. So this is how many observations came off of each site. Table will do that for you if you have a discrete variable. So yeah, let's do, 5 or so more minutes. I'll just cover a couple more things so you can get your money's worth, and then we'll kind of end it and say you can go through the rest on your own. But we will definitely I'll be available to answer any questions about stuff later. Since this kind of stuff, I feel like, since we're not doing stats and things like that, this is possible to kind of learn on your own. If we're doing stuff with stat models, it maybe isn't as easy, but I think these intro lessons might be a little easier to go through on your own time. Once you're already equipped with the tools of knowing how to push the buttons a little bit, you can try stuff and you're not going to break anything, because what the worst happens is you get an error. So you're not going to be able to break the computer by typing in commands in R. So, right. Well, hopefully the USDA computers have guardrails that prevent you from breaking it by typing stuff in. So, okay. So here's another thing that's very important to do with data, which is subsetting the data based on conditions. Obviously, a very important part of data manipulation. Filter is the function in tidyverse if you want to select rows of the data that meet a certain condition. So if we wanted to get only the mammals whose weight was less than 10 grams, the first argument is the name of the data frame, and the second argument is the condition, or more than one condition you want to do. So we already knew that you get a logical vector if you make a comparison. So it will make that comparison and then use that logical vector to pull out those rows. So if you do filter and S mammals is the name of the object, comma, the condition we want to filter by. Weight is less than 10, because there's a weight column measured in grams. If you hit Control Enter, it will give us 14 out of however many mammals have a weight of less than 10 grams. So that's filter, very common. And select is a function that is used to select individual columns, and you can put them in without quotations. If you want to select only the taxon and weight column, taxon ID and weight, you would do it using the select function, or that is one way to do it. So if we do select on the S mammals, taxon ID and weight, Control Enter, it will pull out just those two columns, but all the rows it will keep. Yes, Lauren. Yes. Usually the tidyverse functions are designed so that you do not have to quotate the column names. The base R functions usually do require quotes on the column names for the most part. Yes, that's basically a usual good guideline. Yes, so getting summary statistics on data frames. I think I have a little set of slides to show you how to deal with missing values, but I'm going to gloss over that a bit and just show you the result of getting summary statistics on data frames. Basically, the upshot of it is, if you have even one missing value in a vector, even if it has a million not missing and one missing, and you try to calculate a summary statistic like the max or the mean, it will give you a missing value for that summary statistic as well. Even if just one value is missing in all of it, it will poison the well and give you missing value for any summary statistic based on that, which is a good default behavior because it will make you aware that there's a missing value. You have to explicitly tell R what to do with the missing values, how to get rid of them. Basically, you use the argument na.rm equals true, which means remove missing values before we do the summary statistics. You have to explicitly do that if you're taking the mean, the min, the max, or the sum, or anything like that, or quantiles or whatever. It is a argument to the mean function. Let's see, the skip ahead a bit. Yes, so if we it will, yes. There's two ways to do it. One way is to first filter the data and get rid of missing values, and then calculate the summary statistics in a separate line. The other way is to use the NA remove argument when in the same line as you're calculating the summary statistics. There's two ways to do it. Yeah, I'll just do that real quick, and then we will stop for the day, because after that, the sort of next thing I was going to do is show how to group and get summary statistics by group, like if you wanted the mean weight of every species separately or something, but it's a little extra to explain. So we'll maybe, if we have time, we can like do it another before one of the other ones, but I think we should go just stop at some point so we don't take the whole day. So the last point that we need to know for this is this pipe operator, and this is how you can do multiple manipulation steps on data within one call. It will take the output of one line and pass it to the next line. So if we take the small mammals and use the pipe operator, which is parentheses, greater than parentheses, it will take small mammals and it will pipe it to the next line. And summarize is the function that creates summary statistics. So we're taking small mammals, we're piping that to the next line and summarizing with mean and standard deviation of weight. A greater than sign. Yep. If we hit Control Enter on that, see, we got missing values, NAs for the mean and standard deviation of weight, and that's because there's at least one missing value in that weight column. So what we have to do is first there's two ways to do it. One, we could take the small mammals, pipe it to a filtering statement that will filter the missing values out of the weight column, and pipe that to a summarized statement that will calculate summary statistics. So let's try it that way. So we use filter, and then we have to put an exclamation point, meaning not. And then we use the is.na. So is.na checks if values are missing. So it says, take this weight column, find anything that is not NA, so not missing values, filter to only keep those rows that are not missing values. I don't know why I was away, but okay, maybe it's like we've been on here for 4 hours, so it is. Right. Yes, there are. Yes, that's right. So if there's usually more than one way to do stuff. So let's run this line to filter and then summarize. Now we get a mean and a standard deviation. Or you can put this na.rm equals true, which means get rid of the NAs inside of the summary statistic calculation. But we have to do that individually for every summary statistic we calculate. Control Enter. It's exactly the same result because we did it two different ways. Oh yeah, and it's kind of neat. I'll just say the last thing. The way you get summary statistics by group is the group_by command, which will give you the summary statistics for every group. We're going to do it by species. We still have to do that filter to not NA of weights. Yes, filter, right. So it's a 3-stage pipe. We pipe to a filter statement, getting rid of all non-missing weight values. We're going to group by taxon ID, so all subsequent things will be done by group. And we're going to calculate summary statistics for each group, mean and SD. Control Enter. And you can see that it gives you a mean and standard deviation for every group. But actually, some of the standard deviations are still NAs because they only have one observation for that species, as it turns out. So standard deviation is undefined if you have only one observation in the group. So that's why those values are still NA, even though we actually removed all the missing values from the data. So that's just something to note as well. Yeah, basically the rest of the lesson kind of gives you a little bit more details on some other stuff, but that's kind of like the most important points of that lesson. So I think if you would like to learn more, I would highly recommend working through the rest of the lesson. But that's, yeah, you can see by the scroll bar, we kind of got through about 80% of it. So those were kind of the main points I wanted to hit.